Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. An array is a group of elements of the same type that is stored contiguously in memory. As you can see the following diagram, it shows an integer array which is called C and it contains 5 elements. The type of the array specifies what type of variables the array can hold. And as we said before, that C is an integer array. That means that it can only hold integer values. To refer to a particular location or element in the array, we specify the array's name, which in here it's C, followed by the element's position number in square bracket. The first element of array is always located at position number 0, and the position number is called the element's subscript or index. A subscript or index must be a non-negative integer or an integer expression. As you can see in our example that the array's name is C. The value of the C array 0 index is 45, the value of the index 2 is 0, and the value of index 4 is 1543. A subscripted array name can be a left value. That means that it can be used on the left side of an assignment. So the statement that you can see in here, it replaces C's second index value, which currently it's 0, to the value 1000. And also, as an example, to print the sum of the values in array C's first 3 elements, we would write a statement like this. Also, as an example, to divide the value of element 3 of the array C by 2 and assign the result to the variable x, we would write a statement like this. Last but not least, it's very important that the brackets that encloses an array's subscript is an operator with the very highest level of precedence. So it's always evaluated before any other operator in the statement. And that's it for this episode. I hope this has been informative for you. Stay tuned as we explore arrays in C programming language in the coming episodes. Hello everyone, welcome to this episode, and in this episode let's go and discuss how to define arrays. So to define an array, you need to specify its element type, which for us here it is integer, and also the number of elements, which for us here for the array C, it is 5 elements. And when we specify the number of elements, the compiler may reserve the appropriate amount of memory for that array. As you can see, we have another array which is called B. The type of this array is integer and it will have 100 elements, and array X will have 27 elements. So the range of index that we would have for array C, it would be from 0 to 4. 0, 1, 2, 3, and 4 included. For array B, it would be 0 until 99. And for array X, it would be from 0 until 26. We also have a special type of array, which is a char array or a character array that can store a character string. And we will discuss about that later in the coming episodes. And that's it for defining arrays in this episode. I hope to see you in the coming episodes where we will go into more details of array in C programming language. Hello and welcome to this episode, and in this episode we are discussing about defining an array and then using a loop to set the array's element values. As you can see in here, we have an array which is called n and it has 5 elements. Now here in this for loop, I'm trying to print the value of the elements of the n array. Like any other local variable, uninitialized array elements, they contain garbage values. So if we are trying to print the elements of the n array, they will have garbage values. Now, as you can see here, I'm trying to print the values of the elements of this array using a for loop, and I'm using a counter control variable I, which the type of this variable is size t. The C standard says that size t represents an unassigned integral type, and it's recommended to be used for any variable that is representing an array size or subscript. The type size t is defined here in the std div.h, which this header is included in the standard input-output header, so that's why we do not need to include it. And the conversion specification that we use to print the size t variables, it is this one, ZU conversion specification. Now let's go and run this program, and we can see the values of the elements of array. You can see that we have some garbage values in here. Now let's go and try to set the values for this array. Here we have a for loop which will go through each one of the elements of the array, and it will try to initialize these elements to 0. Now if I try to print the values of the elements of the array, you can see that they are all initialized to 0. And that's it for this episode. I hope this has been informative for you, and I would like to see you in the coming episodes. Hello and welcome to this episode, and in this episode we are going to initialize an array with an initializer list. So as you can see in here, we have defined the array n, which it has 5 elements, and we have defined the elements with an initializer list. Each one of them, they are comma separated. So now let's go and try to print the value of the elements of the array. You will see that all of the arrays are initialized respectively. All of the array elements are initialized respectively. Element 0, 32, element 1, 27, 64, 18, and 95. Now let's assume that we have an array which it has been defined to have 5 elements, but we are providing 4 elements in the initializer list. What is going to happen? Let's go and see that. As you can see in here, the last element is implicitly initialized to 0. And this is what's going to happen if you provide fewer elements than it's defined. Now let's go and assume that if we provide more values than it's defined. So 56, and I will also provide 66. So the array is supposed to have 5 elements, but I have provided 6 values. 1, 2, 3, 4, 5, 6. Now let's go and execute this program. And as you can see, the program cannot be executed because providing too many initializers for an array is a compilation error. So we cannot run this program. But we can make this program work if I try to remove the array size in here. So the compiler will define the array size automatically, and it will define it until 6. Let's go and change 6 in here as well. And let's go and print the array. Now as you can see, the array is properly defined and initialized. Another way to initialize an array is that to provide the array size and then provide only one value for the entire initializer list. For example, 0. Now let's go and print this array, and as you can see, all of the elements of the array are defined as 0. And that's it for this episode. I hope this has been informative for you, and I would like to see you in the coming episodes. Stay tuned. Hello and welcome to this episode, and in this episode we are specifying an array's size with a symbolic constant, and we are also initializing array elements with calculations. So as you can see in this program, we have an array which is called is, and the size of is being specified with a symbolic constant that the value of that symbolic constant is equal to 5. So we have an array of 5 elements. Then using this for loop, we are trying to initialize the elements of the array. So the elements of the array starts from 0, it will go up to size, and as you can see, for each element of the array, we are doing this calculation and initialize the array elements based on this calculation. And finally, we have the header in here, and we will try to print the elements of the calculation using another for loop. Now let's go and run this program once so you can see the results of this program. You can see that an array of 5 elements is being created, and the values of each element is being defined based on this calculation. So let's go and talk about symbolic constants for a while. Symbolic constants are being defined by using this define preprocessor directive. Then we have the name of the constant and then the value of the constant, which in here it is equal to 5. A symbolic constant is an identifier that the C preprocessor replaces with replacement text. So in here, symbolic constant will be used to define the size of the array for the array S, and this size will be replaced by the compiler to this value of 5. And in fact, all the other occurrences of this constant size that we have in our program, they will all be replaced by the real value of 5 before the compiler compiles the program. So in here and also in here, they are all going to be replaced by 5. Using a symbolic constant to specify the size of an array makes a program easier to read and also to modify. For example, if we want to change the size of the array, we simply come here and change the size by changing the value in here. And then we don't have to come in here and also in here and also in here to change the values of all these constants. So using only one constant, it makes it easier for us to bring changes to the program. It's very important to remember that you don't put a semicolon at the end of defining a symbolic constant, because this will become a compilation error, because basically this symbolic constant, instead of becoming an integer, it becomes a string. So if we try to run this program, as you can see, we will have a compilation error. So never put a semicolon at the end of defining a symbolic constant. Also, assigning a value to a symbolic constant in the executable statements of a program is a compilation error. A symbolic constant is not a variable, and by convention we are using only uppercase letters for symbolic constant names, so they stand out in a program. So now if I try to run this program will result in a compilation error because we cannot assign the value of a symbolic constant inside of our program. And that's it for this episode. I hope this has been informative for you, and I would like to see you in the coming episodes. Stay tuned.